Now, this is going to be lesson 2, and it's called of the circle unit, and we're going to be talking about central and inscribed angles of a circle. Now, this is sort of, we've already covered some basic topics. We're going to add a little bit more, and then we're going to continue on learning about central and inscribed angles, and then we'll go from there. Now, the first thing we're going to talk about is what is called an arc. Now, you probably haven't heard of any of these terms before, but an arc is basically the rounded edge of a circle. And basically, we measure this in degrees. So I'm going to add a little note here. We're going to measure it in degrees. Now, it's talking about the not the distance, but how many degrees are in an arc. And we label an arc by putting the symbol AB, and then we put a little rounded part above it. So that will be called arc AB. Now there's two different types of arc, but the ones we're conjuring are called minor arc, and that's basically the smaller of the two. You're going to go from basically the smallest distance, and that's the distance we're looking at when we're talking about it. That's sort of the default. The major arc, for example, would be AB, which is going to be the whole thing, and that's just a lot more work. So one thing you need to know about a circle is that a circle has 300 degrees of arcs. So if I went all the way around the circle, it would be 360 degrees. Okay? Now, let's take a look at some theorems. The first one is basically the arc created by a diameter. And remember, a diameter is a chord that goes through the center of the circle. So BC is basically what happens is it cuts the circle in half. So the diameter created is going is oh, sorry, I messed that up. Creates a semicircle. And if you should have heard this term before, maybe in some science classes, the semicircle is half a circle. Okay? And now a semicircle is half a circle. So if we're talking about arc BC here, which is the diameter, it's going to be 180 degrees. Okay? So basically, the semicircle has 180 degrees in it. Okay? Sorry about that. Now, let's take a look at the next theorem, something we call a central angle. Now, a central angle is an angle created by two radius. Now, when we're talking about the arc, when we're looking at the arc, I have a central angle here of AOB. So AOB is a central angle. Now, when we're talking about the arc that's across from it, that's created by these radii here, I'm talking about what we call something called intercepted. So basically, there's always a relationship between the angle and the arc that it intercepts. In a central angle's case, it's equal to the number of degrees in the intercepted arc. So if I said that AOB, angle AOB is 50 degrees, I know that arc AB is 50 degrees. Okay. It's an easy concept, but just make sure you guys understand. Let's go through a bunch of examples, see how you do. And you guys can feel free to pause the video and do these examples on your own. The first one, the measure of angle AOB is 50 degrees. That's what we just went over this one. I want to know what the measure of arc AB is. Now, arc AB is going to be equal to it, so I'm going to say this is 50 degrees. Let's go through another example. I'm going to tell you that the measure of angle AOB is 150. Whoa, that's big. So, what's the measure of arc AB? Okay, and remember that symbol means arc. Now, if this is 150, that means that we look across from it. We have AB. Therefore, this is going to be 150 as well. Now, the thing is that this whole theorem works in reverse as well. So if I, instead of giving you the angle, I gave you the arc, I said the measure of arc AB is 60 degrees, and I want to know the measure of angle AOB, I know that those two things are equal. So therefore, this here must be 60 degrees. Okay? Easy concept. Make sure you guys understand the central angle is equal to the intercepted arc. Now, let's talk about our next angle that we can create, and it's an inscribed angle. If you notice, an inscribed angle is over here. And our definition for inscribed angle is that it's created by two chords that meet at the edge of the circle. Now, when we're thinking about inscribed angles, what we're thinking about is the measurement that we can create with the arc, or if we know the arc, we can figure out the angle. Now, the relationship is that the measure of an inscribed angle is half of the intercepted arc. Now, this angle ABC is an inscribed angle, and it's intercepting arc AC. Basically, it's creating it with this circle. So, the key thing is, let's look at two examples real quick. If I know the measure of arc AC is 70, I want to know what the inscribed angle is. Now, if we remember, 1/2 of the relationship between the angle and the arc is that the angle is 1/2 the arc. So therefore, I can say the measure of angle ABC is equal to 1/2 of whatever the arc AC is. In this case, it's 70. So therefore, I know that the measurement of angle ABC is equal to 35 degrees. 35. Okay. Now, take a look at one last example. If the measure of angle ABC here is 30, I want to know what the measure of arc AC is. Now, if that's the case, then I know this is 30. I can still use that same theorem. I know that the measure of angle ABC is equal to the measure of arc AC. Or not the measure, but 1/2 of the arc. Now, if that's the case, then I can say I know the measure of angle ABC is 30 degrees, and that's equal to 1/2 of AC. So algebraically, what happens is we can multiply both sides by 2, and I end up getting that arc AC is equal to 60 degrees. Okay? Hope you guys understand this. If you have any questions, feel free to shoot me an email. Thanks. Bye.